My name is Cliff Dubinois, and I'm the Director of Field Marketing for FIreScope. And today's webinar is Securing Your Business, Protecting Your Customers' Data from Hacking. So, to get started, today we're going to have Paul Yates presenting. Paul is our Senior Technical Consultant. He works for our European division. We also have Devin Bradshaw. He's the Director of Sales Engineering for FIreScope in our central region as well. Both of these gentlemen have done multiple implementations of FIreScope solutions. They've run into a number of challenges that our customers are facing, so that makes them uniquely qualified to talk about today's topic. To give you an idea from an industry perspective, according to Gemalto, which is a worldwide digital security consulting agency, 4.5 billion records were hacked in the first half of 2018. They don't have an exact assessment yet of how many records for Q3 and Q4 of last year, but this does mean that there was a 133% increase in the number of stolen records as compared to 2017. Over a quarter of the breaches, 27% of breaches actually took place in the healthcare vertical. Now, what we're seeing is actually a decrease in the number of hacking or phishing incidents that are occurring, but when hacking does occur, we are seeing an escalation in the number of records that are being stolen or held hostage or being put out for the world to see. So with that being said, with the FIreScope approach, our first step in there, the first topic that we're going to talk about today, is understanding how your technology infrastructure supports your critical lines of business. This means mapping out your entire network environment, which leads us to the second point, which is gaining insight in the relationships of your different devices. In other words, which devices should be communicating with each other devices. Finally, with that baseline established, leads us to our third point, which is spotting and identifying unauthorized devices on your network. And more importantly, how does this impact your line of businesses in real time? So with that being said, I am going to turn the presentation over to Paul.
Thank you, Cliff. So as Cliff says, I'm going to try and explain to you why you need to understand your infrastructure and how we can help you achieve that. So your critical lines of business, which we refer to as services, they're delivered by multiple layers of hardware. You've servers, you've got storage, you've got virtualization, you've got networking equipment. Much of that hardware is not only serving one service, but serving multiple services. So not only do you need to know for this service, this server works with this server, you also need to know, but it also services other services to make sure that you've got a complete idea of how everything hangs together. Problem is, over time, knowledge of this server structure is lost through people leaving. The infrastructure itself gets changed. The service evolves, you add bits, you take bits away, you expand its use. Keeping track of all that is very difficult, but critical. So I'd like to ask you a quick question. What percentage of your critical service technology do you believe you actually fully understand? The reason for asking this, you've got 30 seconds or so to answer this, but I'll just explain why. I just wanted you to think carefully about your systems and whether or not you really understand them, and it will give us some idea of whether or not we have a way to help you or not. So just give you a few more seconds. Okay, thank you for that. So the danger of not knowing your services is eventually you will need to change it. You might be moving your data center. This happens quite a lot for our customers. We fill this hole quite nicely. You might be upgrading hardware. You might have to change the hardware substantially. So what do you move? Which bits do you move onto the new hardware? Do you split some services off to one piece of hardware and some to another? And then, of course, the business just might change direction. You might take that service and roll it out to another department, another organization, remove it from one department. Nothing ever stays the same. So the big problem you're faced is that lack of the knowledge of this service can lead to major disruption if all of the elements are not known fully and you're not fully prepared for the change. So the question is, how do we help achieve this? And the answer is simple. We'll provide you full, automatic, and accurate mapping of your services in real time to remove this risk. So the question is, how do we do that? Well, our SDDM product builds service maps from 4 layers of data. First thing we look at is network traffic. This is how we can tell how the servers talk to each other, what ports they're using, how frequently, how much traffic, and from that we can build up a picture of the interrelationships between servers. On top of that, then we'll layer a virtual discovery data, which is where we look at your VMware hosts, and we'll build up the relationship between the hosts and the guests, because it's no good knowing that the guest is a critical part of the service. The host is also critical, because if the host goes down, so does the guest. We'll also look at storage. Most services rely on some form of storage. If it's virtual storage provided with VMware, for example, we need to know that if the service goes down, if the storage goes down, that's also going to impact the service. And finally, we'll look at the network topology, how your routers and your switches all relate to the servers themselves. So we'll build up a picture again, looking at the network traffic and looking at the routers and switches themselves, of how they talk to each other and what services hang off which routers and switches. And from that, we can build you an actual picture of your service. So this is a service map, a typical service map, just showing the application layer. So all we're showing here is the results of our discovery of looking at the network traffic. As you can see here, we've got servers talking to servers. Where we've got multiple lines, that's where they're talking across multiple ports. You can see at the top here and on the left here, we've got little boxes which are representative of load balancers. So this is multiple servers just bunched together to make the screen look a bit tidy. So there's a VIP on this cluster, and there's 3 servers that it services. So this is showing immediately the interdependencies between all the servers themselves. We'll add on to that, as I said before, the virtual layer. So these servers here are virtual hosts, with the purple lines indicating the servers that they are hosting. So now we can see if one of these hosts goes down, it's going to impact this guest, and that's going to impact our service as well. Because we're using virtual service and storage in this example, we can also see some file storage here has been detected, and that's obviously a critical part for all 3 of these hosts. So if that storage fails, all 3 of these hosts fail, all 3 of these servers fail, the service is completely failed. And finally, we'll add the network layer, where we've looked at all the routers and switches, and all the communication between them is represented by the green lines. This is where the picture gets a bit busy, but this is a representation of everything that's required to build that service. At this point, you now know everything that's required for this service to operate. And this is where you can then create a baseline of a known good working service and migrate that data probably into a CMDB as a baseline for change control. So anything that happens beyond that point, it should be under change control, and you need to know about it. So here's an example of how SDDM actually helped a proper customer with their discovery and why we did it and what it achieved. This was a customer who wished to move their data center, but they didn't understand their services. Very typical example. We mapped a particular service, but at the end of the mapping process, there were 3 servers that they didn't understand what they were doing. They didn't recognize them. They went away for a few hours and came back and identified 2 of those 3 and agreed they were part of the service. But they had 1 left and they didn't understand it. And the discussion carried on for a little while, and eventually they said, well, perhaps we should just take it out. We don't know what it is. It's not part of the service. It can't be. We don't know about it. Fortunately, they didn't. 2 days later, they finally identified that final server. It was the jump box from their external support team so that they could support the service they were trying to migrate. Had they migrated without that particular server, the first failure they'd encountered would not only be major, but they'd have had no support on it as well. The support team wouldn't have been able to fix it. So it was absolutely critical that they found that server, and they took the time to go and discover what it was, and they had no knowledge of it. And because it was infrequently used, they couldn't go and they didn't recognize it immediately. So that's one example of how we can help. So I'll now pass on to Devon, who's going to talk to you about how to gain insight into relationships between your devices.
All right, thank you, Paul. So yes, in terms of your device relationship and the insight within those different devices, one of the first questions you want to ask is, what is the level of visibility that you do have into your infrastructure dependencies? Do you know how your network devices relate to your physical servers, or which physical servers relate to your virtual environment? What load balancers you have available, kind of similar to what Paul showed in some of the last slides. Are new devices being brought on and off your network without full visibility of the impact of either standing up a new server or decommissioning a new server? What other applications are affected by standing up or decommissioning a server? If you don't know those relationships, then you have a very high risk of affecting other additional applications or business services if you do not know those relationships. Are you quickly able to determine if bringing a new device on or off your network affects other applications, which kind of goes back to kind of the relationships and the different applications, because one storage server, one database server might house multiple different applications. Your web server might be part of a web farm, and there might be 4 or 5 different websites, which are all kind of interconnected. So understanding the level of the device relationship within your environment is extremely important. For DNS, for example, are your devices receiving DNS from valid DNS servers? Are there potentially rogue servers or rogue devices on your network that are sending out DNS entries? Your PCI zones through non-PCI zones. Are those zones really truly segmented? Do the network team or the virtual team say that they're segmented, but it actually is not? Is there any unauthorized communication between those zones? How can you determine that other than, the network team saying, yes, we definitely segmented that? But how do you know exactly real time if there is unauthorized communication going between those two zones? So that kind of leads us to kind of the importance of that valuable device relationship insight. So if you think back to what Paul was talking about a little bit earlier and showing in this screenshot that you see here, you have both application traffic, virtual dependencies, and also the storage relationships. All of those are shown along with load balancer and cluster information. So now that you know not only this particular application, for example, what the interdependencies are here, but you can also see within our product also what other applications that device is associated with. So this would allow you to do is be more efficient in your incident or event management. It's also made easier by knowing your upstream and downstream relationships and dependencies. If you know those, then when you're trying to triage an incident, you can easily triage it because you know what applications are affected by a particular outage. It makes it easier to secure your environment. If you know the interdependencies and you know your single points of failure, then you can manage around that and try to minimize that risk. It also brings an additional awareness of infrastructure, like I stated, single points of failure. For example, in the screenshot you see here, one of the hosts actually have 2 guests that are associated with our web VIP. And that's a single point of failure. If that host goes down, 2/3 of your web farm goes down. So how do we gain this valuable relationship insight? By utilizing SDDM, you have the ability to view device-to-device communication within your network. We do that by doing passive network monitoring so we can identify the application and transaction flows, and then also piece together some additional discoveries to help enrich those dependencies. It also, with our passively listening to that network traffic, allows us to auto-detect some service endpoints. Look at some locations or some scenarios where you have unique IP addresses connecting to a particular server. You can use that for some kind of detection and creating some service maps. And one other thing that it allows us to do is kind of changes are identified as they occur. If you bring a new server onto the network or one drops off, our solution will be able to determine that and specify and let you know that a particular device is either lost communication or there's a new connection. Additionally, with this, we're also easily able to filter traffic to look at specific subnets in your network. And we can utilize that information, that traffic information, to generate service maps to show some of those application dependencies. And then, like I stated earlier, kind of utilize some of the other discovery methods, the virtual discovery, the network discovery, topology discovery, and storage discovery, to kind of stitch together other dependencies within the application to application traffic. So one use case that we did in one of the deployments that I did was a healthcare organization that had previously dealt with the WannaCry ransomware. Now, for those who don't know, the WannaCry ransomware is just malware meant to ransom money from a victim by threatening to encrypt or delete data from an organization. By encrypting the data and making it unusable, unreadable, or even threatening to release data into the public sphere. So their challenge that they had after dealing with that WannaCry ransomware was to validate that all SMB traffic was secured and that it was either disabled or managed in a way that they knew exactly what SMB traffic was communicating with what. And really, at that time, they had no way of truly seeing if all SMB traffic was disabled or not. And if it wasn't, then they also needed to identify if there were any devices still communicating SMB traffic on the network so they could remedy that situation. So in their initial remediation, they tried normal traffic capture options. So like packet capture, look at the flows from there, and then try to make a determination if that traffic or if there are some unknown devices communicating with that SMB traffic. However, this failed because they could only take a snapshot of traffic in time from the packet capture. And since they were unable to view near real time offending devices communicating on the network, this is why they kind of brought us in. So we were able to, once we have flow traffic sent to our collectors, we were able to filter traffic and create a map of all SMB traffic within minutes. And what that did was that showed that significant SMB traffic was still communicating on the network. And it allowed the network and server teams to be able to quickly remediate any traffic not initially identified. So I have a question. So we're going to take about 30 seconds or so to start the question. So the question I have is, what is the percentage of visibility that you feel that you have in the relationships between the devices and your environment? Do you feel your percentage of visibility is under 50%, between 51 and 70%, between 71 and 90, or above 90? And we'll take about another 30 seconds or so to answer the questions, and then we'll continue. Okay. All right, and I'm going to pass this back to you, Paul, so that we can talk about spotting and identifying unauthorized devices on your network and how it'll impact your line of business in real time. Go ahead, Paul.
Thank you, Devin. So as Devin says, I'm going to talk to you about how you can find devices on your network and that shouldn't be there. Why do we need to do that? Well, you have a responsibility to protect your data. All businesses have a responsibility to protect their systems and their data, and an even greater responsibility to protect the data of their customers, suppliers, and third parties. A lot of our work is done with hospital organizations. If you were to leak hospital data, that's private, personal, people's information that can get out in the open. Critical that that doesn't happen. So now there are legislation in force in many countries in USA and Europe that put severe penalties around for if you don't safeguard this data. Any device which gains access to your network, physical access, has already bypassed many layers of your security. They're already in and got connection, and that makes it much easier for them to access your critical data. How can we detect when an unauthorized device is connected to your network? If you've gone through the process I described earlier, where you've mapped your services and you've set the baseline and committed it to the CMDB, you've got what should be a good starting point. So we know that everything in that forms the service, and that's what we should see at all times. Our solution contains real-time monitoring of the network traffic. And if it sees something change on that service, we can let you know. New device has popped up. It's part of the service. It shouldn't be there, allowing you to go and perform an immediate investigation. If the device is actually part of the service, something's changed, maybe the change control hasn't gone through, then fine, that's okay. We'll accept that change, put it through to the CMDB again, form a new baseline. Everything's back to normal. But if that device is unknown, then you've got the ability to take prompt action to go and find it. Zoom into the software, find out what its IP address is, work out which switch it's attached to, go and look at those ports, see if you can find out what it is, see if you can find it, if not disconnect it, and prevent any further damage. So the earliest possible opportunity to see that something is there that shouldn't be there. Here's an example of when we've done this. We had a brand new customer. I'd literally been on site for 2 hours, and most of that 2 hours was spent with the initial kickoff meeting and the first cup of coffee in the morning. Previous to this, we had installed the software remotely and we had got all the network flows set and we were collecting data. So we had everything in place. We finished our kickoff meeting, the coffee, we sat down, the IT manager said, can you show me some proof that you are collecting the data, that you've got something to that you're building? And this is quite normal. So I showed them what I call our network topology map. This is the entire network seen from above, everything talking to everything. And when you do that, you expect to see something that looks a bit like this. So you haven't seen our software before. What we're looking at here is very, very zoomed out, an entire network. These dots are servers, or could be routers or switches or printers or any connected devices. And the lines between them are communications between those devices. So this one here, for example, there's 3 or 4 lines of communication there, so it's talking over 3 or 4 ports. That's normal communication, that's what you expect to see. However, in this case, this is not what I saw. What I actually saw was that. Immediately set alarm bells were ringing. This is indicating that multiple ports are being attacked on multiple servers. So deep in the middle of here somewhere, there's a machine talking to many servers on many ports. So what we discovered by drilling down into that, there was an internal device that was port scanning many other devices. Now, why is that a problem? Port scanning is an indicator, an attempt to gain access to a device. If you look at the ports, so port 80, for example, is a web server typically, port 21 is an FTP server, and there's many, many ports, many, many different ones. If you get a response to that port, you know that there's a piece of software running behind it, hosting a website, hosting an FTP server or something like that. If you can then find out what that is, you can look up, find out what known vulnerabilities there are in there and see if you can exploit them. So that's exactly what this is indication of. Somebody's trying to get in, gain control of that device. And if they use an exploit and get control of that device, they're then able to attack the entire network, which is not a good place to be. In this case, the device belonged to a contractor and was not malicious. So fortunately, it wasn't an external body trying to get in. It was a contractor actually doing something he'd been asked to do. However, he was supposed to have finished that work 2 weeks previously. He was accessing the network remotely and his remote access had not been revoked. No one knew this port scanning was taking place until we produced this map. So the company took this very seriously, and they had serious security and process issues which they had to address, which were totally unknown until we produced this mapping for them. And this was done just by collecting network data and just looking at the map before we'd actually started any of the real work. So with that, I'll hand back to Cliff for the summary.
So in quick summary here, what we talked about today, understanding how your technology supports your critical business services. This is a vital first step in mapping out your environment and making sure that you understand all the devices that you currently have. This leads to the second bullet point, which is having insight into the device-device relationships inside of your environment. So if you have a secure database, for instance, what devices or applications should be communicating with that particular database. Finally, with bullet points 1 and 2, you have a baseline established. You can now see when an unauthorized device connects to your network. So for instance, your secure database, if there's another device that pops up on the network, you can immediately launch an investigation to find out why that particular device is connecting. So with that being said, for the webinar attendees, we have a special offer. So we do have for our FIreScope SDDM solution, Secure Discovery and Dependency Mapping solution, we have a community edition. Normally when we offer this to the general public, we have a limit of 50 CIs on this, but for today's webinar attendees, we are offering this trial version of 100 CIs. Plus, we're going to give out 1 hour of consultation with our FIreScope engineers, not only in setting up the device inside of your environment, but showing you how to get value from the tool. Look for that email to follow this webinar. And with that being said, Q&A time. I actually did have 2 questions that came in. So the first question is, what sort of access do you need to the network to be able to map out your services? Paul, since you talked about that, I'll let you field that question.
Oh, okay, thank you, Cliff. So to map the services, we need network traffic. We don't need admin rights to any of your servers. We don't need to be able to put software on those servers. We just monitor network traffic. So we look at getting you to supply us with NetFlow, SFlow, promiscuous traffic, port mirroring, network tap, any of those, any combination of those, so that we can literally look at the headers of that traffic and work out that machine A is talking to machine B on port C, and how frequently and at what times. And from that, we can then build that picture. For the scans that we do on top of that, the virtual scan, we need read-only credentials to your hypervisor. And then for the other things like topology mapping from your network devices, load balance querying, we just need read-only SNMP access. So we only ever need read access. We don't need any admin rights. We don't need to install any software.
Excellent, thank you for that. The second question, how long does it take before we can start to see our device-device relationships? In short, what's the time to value? Devin, could you field that question?
Sure, Cliff. Usually, as long as the traffic flows are being sent to our traffic collectors, our edge devices, we could have service maps generated in minutes. It's really just a matter of if the end user knows kind of where to start with the maps, and we can build them out very quickly.
Excellent, thank you, Devin. Okay, everyone, that concludes our webinar today. Like I said, keep an eye out for that email to follow shortly with the special offer to download FIreScope SDDM. And on behalf of all FIreScope, once again, thank you for your time and make it a great day.